Hello. So I want to talk about classification of lidar data. When you get a bunch of lidar data, you want to classify them. I don't think. Well, ArcGIS, there's some really nice lidar functions, but it's better to use other tools. In this case, I think Global Mapper is a really good one. You could, but before you do that, make sure you save. So see here, this is lidar map, right? Lidar data. Just make sure you right click the map frame and you can save. You can right click and save projection file. That's really important. Okay. Once you save projection file, you when you go to global mapper, you open up your file. See here, I just give example. Um, and you could load the file. Okay. Once you load the file, then your see here, this is the online map. You can choose the online map. Then your lidar data and your imagery, they can match up. Okay, that's super important. Okay, if you don't do that, they won't match really well. Okay. um, and then the classification in here is pretty straightforward. This tool are all the I'd say really like automatic ones. The first is noise control. Let me pull up some web page here. So this is the noise control. You want to do this first, okay? So based on the standard deviation, okay, if there's more than, I usually use 3. It's more than, it actually works really well, okay? If it's more than 3 standard deviation, then you better don't do that, which means it just suddenly pops up, okay? And it's just 1 point down there, okay? um, so this is this, and then once you figure out the noise, then by the way, when you do this, please check this: reset the existing noise point to unclassified at its start, which means in previous lidar data they might already classify some noise data. If you check this, they will make this existing classified data to be unclassified and do it again. So that's really important, okay? um, Again, every function you want to check this, okay? Reset existing ground points, okay? That's really important. This is really obvious. You could they also have web page to tell you what those means. So what they mean, okay? So this is a ground classification. They have it's really straightforward. They tell you what that means, what stuff means, okay? um, After the ground, then you classify the non-ground, okay? For non-ground, I want to talk a little bit more. So the first is beam size. I like to use meter, don't use point, because the point, they have different size. So 1 meter, which means when they calculate, they will have they use 1 point as diameter to find out the laboring points. Okay, this minimum height, and I can show you here. This minimum height is this one, so which means your other point have to be this high, and the maximum coplanar distance. What this means is, I figured out is, for example, if you have points, I just draw down here. If you have points, sorry, if you have points, let's say this is a point, this point, this point, right? They will start to draw a plane, okay? And then if you have 1 point, that's a little bit off, right? So this happens, right? Then that's there's a distance to that plane, okay? Basically that's what that means. And when they find the plane, it's based on the diameter, okay? Based on the beam size, okay? Which is this one, the base beam size, okay? So which means, if it's 0.1 meter, usually I think the roof, buildings, they have roofs, right? If there's a roof, usually they have some bumpy places or things, okay? Minimum vegetation distance. This is another way. If you look at this one, you see this is vegetation distance, which means, because vegetation, they're not flat, right? This is vegetation, they're flat, right? But for vegetation, we need some crowns, which means there's highest point, there's lowest point. So you need to figure out at least what's the minimum distance of that. Okay, what's the minimum distance for a crown like this? Usually a crown is like this. Okay, this is this. There's another one. There's another one. Okay, this is minimum. Just like that. Okay, you don't want to make it too large, but you don't want it too small. So here I make 0.6, probably too big. The other thing you want to make sure is the minimum vegetation distance have to be bigger than the maximum coplanar distance. Okay, the angle difference, again, you can just search online to check their tutorials. It's basically just just in case your roof is a complex one. Okay, and then you click OK, and then they will classify them. The result is pretty good, not that bad. If you want to go to detail and change a little bit more, let's hide the word. If you want to change something a little bit more, it's pretty easy. You can just select them and you right click. You can edit. Okay, really easy. You can edit you can even edit the height. Okay, you can edit the class. Okay, that's the way to do it. Well, to me, it's an easy way. Okay, and then the other thing, you can look at it. There's 3D view. But this 3D view, you can just see the whole scenes. Okay, well, see here, that's what the 3D view is. Kind of complex. Just a lot of stuff going on here. I don't know where. Anyway, okay, it's here. Anyway, you will figure this out. Okay. It's just like a window to see it in the 3D. But the best one I like is this path profile, which means you could just draw a line and you right click to confirm, and then they will tell you what is the points associated with that profile. Okay, and this path profile, they have see here, there's an edge, and they even have buffer zone. Okay, so you see more. Okay, and then the other thing really important is when you show color, you see you can show color by classification or elevation, right? When you show classification, you want to make sure you have legend here. Okay, the way to set up is through here, this configure, and you want to make sure there's display options, there's map legend. Make sure you pick this one, okay, and then they will always show up. That's really important down there. I think basically that's all. That's it. And once you change this LAS file, see this is the LAS file. You just they already save it. So you don't even need to save this workspace. They already updated the file. So you can just close it. And once we close it, you can refresh your GIS file, and this same file you open in Global Mapper, they will update here. So it's basically the same points. Okay, so it's gonna be showing up like this, like the same thing. Okay, that's what that means. I think that's it. You want to use Global Mapper to do some pre-processing and then move to ArcGIS and do stuff you want. Okay, basically that's what I mean down there. Anyway, it's a really good software. I'll try it out. There are a lot of online things you can figure out. But the major process is, if you want to do classification, use Global Mapper. Okay, thanks.